Welcome. In this video, we will review multiplying fractions using models. Let's get started. On your notes page, please fill in each of the blanks as I write them during the video. You can always pause the video for more time to record your answers. Now, let's begin. We know that multiplication is repeated addition. When we say 3 times 4, we mean 3 groups of 4 or 3 added 4 times. We can use this information to multiply fractions. 1/5 plus 1/5 plus 1/5. When we add 1/5 3 times, we get 3/5. Another way to multiply fractions or to think about multiplying fractions is using models. In our example, 8 times 1/4. What we will do, we will follow this step. Step 1 is to draw the same number of circles equal to the whole number. So our whole number in this example is 8. So we will draw 1, 2, 3, 4, 5, 6, 7, 8 circles. In step 2, we will now divide each circle into the number of parts equal to the denominator. Our denominator was 4, so we will divide each circle into 4 parts. 1, 2, 3, 4. 1, 2, 3, 4. 1, 2, 3, 4, and so on. In step 3, we will shade the parts in each circle equal to our numerator. Our numerator was 1, so we'll shade one part in each circle. Next, we will add up each one of those parts of each of the circles. We will add 1/4 8 times to get 8/4. Now, 8/4 is an improper fraction. We can use our strategy of writing 8 tally marks, 1, 2, 3, 4, 5, 6, 7, 8, and then circling groups of 4 because our denominator is 4, 1, 2. So we have 2 whole groups of 4 tally marks in each with no tally marks left over. So our answer for 8 minus 1/4 equals 2. Step 4 was to add the shaded parts to get the answer to the multiplication problem. In the last slide, I got a little ahead of myself, but here you can see that answer again. We add 1/4 8 times to get 8/4, and then we convert 8/4 into a whole number, which is 2. Another strategy for multiplying fractions is to follow these 3 simple steps. Step 1 is to keep the denominator the same. So we have 4 times 2/9. We will keep the denominator the same. Then step 2 is to multiply the whole number and the numerator. Our whole number is 4. Our numerator is 2. So multiplying 4 times 2 equals 8. Step 3 is to simplify if needed. We can simplify 8/9. We can't simplify 8/9, so our final answer is 8/9. Now, it is your turn to try some problems on your own. Pause the video and work through the 6 practice problems for this video. When you have done your best to answer each problem, play the rest of the video to check your answers. Make sure you correct any problems you may have missed. Good luck. In number 1, we are asked to multiply 2/3 times 6. We will do so by using models. First, we will draw 6 circles. Here are our 6 circles. Next, we will look at the denominator of the fraction to tell us how many parts that we need to divide each circle in. The denominator is 3, so we'll divide each circle into 3. Now we have our 6 shapes divided into 3 parts. Now we will look at the numerator, which is 2, and it will tell us how many parts to shade in each circle. In this case, we'll be shading 2 parts per circle. Now that we have our circles shaded, we can write a fraction to represent each circle. The shaded area is 2 out of 3. We can write this problem as a repeated addition problem. 2/3 plus 2/3 plus 2/3 plus 2/3 plus 2/3 plus 2/3. Now all we have to do is add. Because we are adding and our denominators are all the same, our denominator will stay the same as 3. Now we just add the numerators. 2, 4, 6, 8, 10, 12. This is an improper fraction, so we need to convert it to a mixed number. We can do so by drawing 12 tally marks. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. We can continue with changing to a mixed number by then grouping these tally marks into groups of 3. We're going to circle every group of 3. There's 1, 2, 3, and 4. So we can see that this improper fraction converts to the whole number 4 because we have 4 groups of 3 circled with no leftover tallies. So 2/3 times 6 equals 4. Now let's do this with the other strategy, where we'll take 2/3 times 6. We will rewrite the denominator because it will stay the same, and we will multiply the numerator and the whole number. So that would be 2 times 6, which is 12. So we still get the same improper fraction, and we know that 12/3 is equal to 4 wholes. For this problem, we can continue to use the strategy of multiplying a whole number by a fraction using models. We will first draw 8 circles. Now that we've drawn our 8 circles, because we have 8 as a whole number, we will look at the denominator, which is 2, and we will divide each circle into 2 parts. Now that we have our circles divided into 2 parts, we will look at the numerator, and we will shade in that number of parts in each circle. In this case, our numerator is 1, so we will shade in 1 part in each circle. Now that we've shaded each circle, 1 part in each circle, we can now write a repeated addition problem to solve this multiplication problem. So this is 1/2 plus 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 1/2 equals. So we write a fraction to represent each circle. Then we add them. Because we're adding, the denominator stays the same, and we'll just add the ones. 1, 2, 3, 4, 5, 6, 7, 8. So we have 8/2. That is an improper fraction, but we can convert that to a mixed number by drawing 8 tally marks. 1, 2, 3, 4, 5, 6, 7, 8. And then we can use the denominator to know how many tallies to put in each group. We need 2 in each group, so we can circle groups of 2 tallies. There's 1, 2, 3, and 4. So 8/2 is equal to 4 wholes. We have 4 equal groups of 2 tallies in each. So 8 times 1/2 equals 4. We can also use the other strategy to solve this problem by taking 8 times 1/2. We rewrite the denominator, and we multiply the numerator and the whole number by each other. So that would be 8 times 1 is 8. And we get the same improper fraction, 8 halves, which is equal to 4. Number 3 is 5/6 times 3. We're going to continue to do the same strategy by drawing 3 circles. That's the number that is equal to the whole number. So we're going to draw 3 circles because our whole number is 3. Now that we've drawn our 3 circles, we will look at our denominator to tell us how many parts each circle should be divided into. In this case, our denominator is 6, so each one of our circles should be divided into 6 equal parts. Now that we divided each circle into 6 equal parts, we will look at our numerator to see how many parts in that circle we should shade. So each circle should have 5 shaded parts. All right, now that we've shaded 5 equal parts in each circle, we are going to write a fraction to represent the shaded parts in each circle. So our fraction would be 5/6. And then we're going to use repeated addition to find our answer. So each one is 5/6. Okay? Because we are adding, our denominator stays the same, and we will add the numerators. 5 plus 5 is 10. 10 plus 5 is 15. Now, we can convert this improper fraction by drawing 15 tally marks. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15. Next, we will use the denominator to tell us how many tally marks we need to have in each group that we circle. We have a 6 in our denominator, so we need to have 6 tally marks in each of our groups as we circle. So here's 1, and here's 2. Each one of those groups have 2 tally marks. So 6 tally marks, so the 2 groups become our whole number. And the 3 leftover tally marks become our numerator, and then we write that over our denominator. We write the 6, the denominator is the same. Now we know that 3/6 can be simplified. So 3/6, we can take the factors over here. Factors of 3 are 1 times 3. The factors of 6 is 1 times 6 and 2 times 3. We see that 3 is our greatest common factor, so we can divide the numerator and the denominator by 3 to get a simplified fraction of 3 divided by 3 is 1, and 6 divided by 3 is 2. We rewrite our whole number with our new simplified fraction, and our answer for 5/6 times 3 is 2/2. Now we can use the other strategy of multiplying 5/6 times 3 by rewriting the denominator and then multiplying the whole number times the numerator. 5 times 3 is 15. We receive the same improper fraction, and as we convert it to a mixed number, we will get the same thing, that our answer will be 2.5. Number 4 is 12 times 3/4. We'll continue with solving these problems by using models. Our whole number is 12, so we will draw 12 circles. After we have drawn 12 circles, we will look at our denominator to know how many equal parts we need to divide each circle into. Since our denominator is 4, we will divide each one of the circles into 4 equal parts. After dividing each circle into 4 equal parts, we will now look at our numerator. Our numerator is 3. This number tells us how many pieces or how many parts we will shade in each circle. Now that we've shaded in 3 parts in each circle, we will write a fraction to represent each circle and then use repeated addition to find our answer. So we have 3/4 plus 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 3/4. We will keep our denominator the same and we will add up the numerators. 3, 6, 9, 12, 15, 18, 21, 24, 27, 30, 33, 36. So we come to the improper fraction of 36 over 4. We can solve this by drawing 36 tally marks to represent our numerator. Okay, now that we've drawn 36 tally marks, we will look at our numerator. Our numerator is 4, so therefore we're going to circle tally marks and group them into 4 tally marks each. So we have 1 group of 4, 2 groups of 4, 3 groups of 4, 4 groups of 4, 5 groups of 4, 6 groups of 4, 7 groups of 4, 8 groups of 4, and 9 groups of 4, for a total of 9 whole groups. We don't have any tally marks left over, so we don't have a fraction. So 12 times 3/4 equals 9. We can use the other strategy by multiplying 12 times 3/4. We keep the denominator the same. We multiply the numerator and the whole number. 12 times 3 is 36. And we know that the improper fraction 36/4 is equal to 9 wholes. Number 5 is 4 times 5/8. We'll continue with using a model to solve this multiplication problem. Since our whole number is 4, we will draw 4 circles. Now that we've drawn 4 circles, we will look at our denominator. It says 8. Since our denominator is 8, we will divide each circle into 8 equal parts. Now that we've divided each circle into 8 equal parts, we will look at our numerator to tell us how many of those parts we need to shade. Each circle we should shade 5 parts. Now that we've shaded 5 equal parts in each circle, we can write a fraction to represent each circle. There are 5 shaded parts out of 8, and we can use repeated addition to find the answer to this multiplication problem. That's 5/8 plus 5/8 plus 5/8 plus 5/8 equals. The denominator stays the same, and we add the numerators 5, 10, 15, 20. Now we can use our same strategy for converting improper fractions to mixed numbers by drawing 20 tallies, because the numerator is 20. So that'd be 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20. Now we can look at our denominator 8 and we can draw circles around 8 tally marks. 1 and 2. We have 4 tally marks left over. So we have 2 whole groups with 4 tally marks left over as our numerator over our denominator. So 4 times 5/8 is equal to 4/8, but I know that 4/8 can be simplified. So I'm going to find the factors for 4, which are 1 times 4 and 2 times 2. Now I'm going to find the factors for 8, which is 1 times 8, 2 times 4. And then I'm going to see that its greatest common factor is 4. So I'm going to divide the numerator by 4 and the denominator by 4 to get my simplified fraction of 1/2. So my final answer, don't forget to rewrite the whole number, is 2 1/2. And yes, I can use the other strategy of multiplying 4 times 5/8, rewriting the denominator as 8, multiplying the numerator by the whole number, which is 4 times 5 is 20, and I will get the same denominator, or the same improper fraction of 20/8, and we know that that improper fraction is equal to 2 1/2. Number 6 is 10 times 2/5. This time I'm going to look at my whole number, and my whole number tells me how many circles or rectangles to draw. This time I'm going to draw 10 rectangles. Now that I've drawn my 10 rectangles, I look at my denominator to know how many equal parts I need to divide my rectangles in. In this case, 5 is the denominator, so I'm going to divide each one of my rectangles into 5 equal parts. Now that I've divided my rectangles into 5 equal parts, I'm going to look at my numerator to tell me how many parts I need to shade in each rectangle. In this case, I need to shade 2 parts in each rectangle. Now that I've shaded 2 parts in each rectangle, I'm ready to write a fraction for each of these that represents each of these rectangles. So each rectangle has 2 out of the 5 shaded. So I can do 2/5 plus 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 2/5. And I can use repeated addition to find the answer to this multiplication problem. Because I'm adding, my denominator stays the same, and I add my numerators: 2, 4, 6, 8, 10, 12, 14, 16, 18, 20. My improper fraction is 20. I know that I can convert this improper fraction to a mixed number by drawing the number of tallies equal to the numerator, which in this case is 20. So it's 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20. Now, I look at my denominator to know how many tallies to put in my groups. So, I'm going to circle groups of 5 tallies. 1, 2, 3, and 4. So the improper fraction of 4, or 20/5, is equal to 4 wholes, because I have 4 groups with no tallies left over. So 10 times 2/5 is equal to 4. Once again, I can use the other strategy of 10 times 2/5 by rewriting the denominator 5 and then multiplying the whole number times the numerator, which is 20. And then we know that the improper fraction of 20/5 is equal to 4 wholes. This concludes Lesson 6, Multiplying Fractions Using Models. Always remember that a hard-worked wrong answer is always better than no answer at all. It is better to try and fail than to never have tried at all. Until next time.